15 or 16 days, that is after conception, the angioblast. Now, an angioblast is a stem cell. It's a stem. Angioblast begin to show in the extraembryonic, that means outside the embryo, of the yolk sac. Okay, within 15 or 16 days, angioblast. Now right here, by the 4th week, blood islands. Now here's the blood, where's my book? Alright, right here. Okay. Blood islands. Now this represents right here. This says right here, look at this. That says, and you can read, what under the caption, what does that say right there? I can read it, but I want you to read it out loud.
The development of blood.
Islands. Oh, there you go, buddy. You got it. The development of blood islands is what that says right there. That's what that little caption says right there. The development of blood islands. Okay, now that's very early on. Alright, space in these islands. Okay, now listen carefully. Space in those islands, and if you can see this little chart, you don't need to, the very bottom, there are 3 little diagrams there. The very bottom one, inside that circle, what does it say, Shannon? What does it say, Shannon? At the end of every bottom says, do you see a word that says endothelium? You see a word that says endothelium? You might not can read from where you're sitting, but the very bottom one, you see an endothelium. Alright, so very early on, and we're not going to spend much time with this, but I want to kind of show you this. Very early on, spaces will become blood outcomes. Space in these islands are lined with endothelial cells. Spaces will become the lumen. What is lumen from 2401? What is a lumen? A space. A lumen is a space. Will become the space of blood vessels. Then it goes ahead and says, primitive stem cells are produced from these divided primitive stem cells. Now listen, they don't give a name to these cells. They are nucleated. They're nucleated. These cells give rise to the first cells resembling nucleated, there's the word nucleated, red blood cells, which are capable of transporting O2 and CO2. Plasma secreted by these same endothelial cells. Budding of the endothelial cells also extends the next network of vessels. All this happens early. It all happens early. By the 4th week, these blood islands. Spaces in these blood islands are lined with cells known as endothelial cells. These endothelial cells give rise to a stem cell that's capable of carrying oxygen and carbon dioxide. Also, these endothelial cells secrete stuff that's similar to plasma. And the extension of this is little vessels that start permeating through that little young embryonic stage. Why? Because the yolk is limited. The yolk is so limited that, we've got to have another source. That's what the placental hookup is. We are placental mammals. I will never have a placenta, but some of you will. Okay, you will have a placenta. Okay. All right. So there's the way that works. By the 5th week, body mesenchyme produces blood cells. By the 5th week, as the body do it, mesenchyme is undifferentiated tissue. Mesenchyme is derived from mesoderm. Mesoderm is that is an embryonic term, mesenchyme. It's derived from mesoderm. It's undifferentiated, but by the 5th week, mesenchyme begins to produce blood. Now, notice this. I just wanted to show you. It's kind of interesting. When you and I were developing, by the 6th week, the liver. And now the liver doesn't produce blood in us. The liver does not produce blood with us. But in that little developing, see, it's still in the embryonic stage. What is the embryonic stage? From the time of conception through the 8th week. Y'all remember that? Through the 8th week, everybody, is the embryonic stage. Then, by the 6th week, the liver begins to produce blood cells. 7th through the 13th, the spleen found. Now, I'm not so concerned with all this. You might need to you don't need to realize it. You need to know what mesenchyme is. Undifferentiated embryonic tissue derived from mesoderm. Do have an idea, because this is so different from in me and you. This is so different from in me and you. Our livers don't produce blood. You might want to hang on to the fact that the liver begins to... I have a question, y'all. I have a question on your... James, this is probably tuned up by now. Okay, it is. 5 missed calls. One take, okay. No, teasing. All right, okay. All right, now, okay. No problem. Now, everybody, one of the things in us, just remember that the liver begins to produce blood cells at one point, which that's so far removed from us. That's in the embryonic. And then the spleen never produces blood. The thymus doesn't produce blood. Lymph nodes don't produce blood. Now, lymph nodes might produce some white blood cells, but most of it's produced by about the next thing coming up. And again, don't get too bent out of shape over that right there. Oh, they just kind of highlight the word that I did, the liver. Oh, I know what I was going to say. I have a question. I have a question on your test that has something like this. Which of the following would not produce blood and this is a real question. Which of the following would not produce blood in the embryo? And I have maybe mesenchyme cells, liver cells, primitive tubular heart. It does not. In other words, being familiar with what does, you can pick out something that does not. In other words, you and I have a heart early on that looks like a fish heart. It's a tube. Looks just like a fish heart. Remember what Ernst Haeckel said? Ontogeny recapitulates phylogeny. Do y'all remember that term vaguely? Vaguely? Ontogeny recapitulates phylogeny. That means individual development repeats phylogenetic ascent. In other words, we go through stages. I didn't say we were. I say we go through stages in development that resembles primitive animals, more primitive animals. Our heart, at one point, looks like a fish heart. It's a tubular thing, not a four-chamber thing. We go through the development of it. So, right here, the spleen, the thymus, so you could pick out something. In other words, lymph nodes produce blood at one point. Spleen produces blood. The thymus produces blood. The liver, but what doesn't? Primitive tubular heart doesn't. Okay? The proctodeum doesn't. What is the proctodeum? Primitive anus. It doesn't produce blood. Okay. All right. So then from the 13th week on, y'all, the bone marrow and lymph organs, lymph nodes do retain here some of the work, but the bone marrow is the main producer of blood for us. Now remember, I talked to you about a type of anemia where the bone marrow shuts down. What was that type of anemia? Y'all remember it? Good job. Way to go, buddy. Aplastic anemia. Now you and I don't ever want that. First time I really read about that was at the end of World War II, when we bombed Nagasaki and Hiroshima with the atomic bombs, which shut down the war with Japan, and it shut them off immediately. That shut it down. That stopped it right there. And millions of people, many people, suffered from radiation, the effects of the radiation, and aplastic anemia, the bone marrow. Man, you don't want that. You and I don't want it. Okay, now let me ask y'all this. We're going to cover this in microbiology. There is right after World War II, in about 1947, there was a broad-spectrum antibiotic called chloramphenicol. Chloramphenicol came on the market. It's cheap. It's very cheap now. I mean, it's good, but you will never take chloramphenicol. Because one in about every 200,000 people that take chloramphenicol or took it got aplastic anemia. Now, if you got aplastic anemia, you were dead in the water. So you and I don't take. I had a guy from India in my course. His name was Fernando. Fernando was about, he was in his mid-40s, and he was going home to India. In fact, he had a sibling, a sister, who had pancreatic cancer. She died. He thought she was going to get better, and we talked about that. She didn't. She died. But anyway, I said, Fernando, when you go back to India or talk to anybody, ask if chloramphenicol can be gotten or if it's prescribed in India. Well, he reported back, says, no, it's not. So I don't think it's, but one of the side effects of that was lethal. A side effect of that was aplastic anemia.